Okay. Now, when you're dealing with very dilute solutions, a few things you need to be aware of, which would be really helpful, is that molarity and molality are almost the same if you're dealing with very dilute aqueous solution. Why is that? Well, remember, remember that 1 gram of water has a volume of 1 milliliter, right? So the density of water is 1 gram per mil, or 1 kilogram per liter, 1,000 grams for 1,000 mils. So if you have a small amount of solute, okay, remember if you have very dilute solutions, you have a very small amount of solute compared to the amount of water, so it will hardly affect the density of the water. So in very dilute solutions, we say then that 1 liter of solution will essentially be 1 kilogram, right? Will weigh 1 kilogram. And that will be pretty much 1 liter of solvent and 1 kilogram of solvent. We're saying that if you're dealing with very dilute solutions, the total mass and the total volume is essentially that of the solvent. So you don't care whether you're dealing with solvent or solution. And so your molality, so moles per kilogram of solvent will be the same as moles per liter of solution. So if I have like 0.01 molar solution, chances are it's also 0.01 molar, provided my solvent is water, okay? Because it's important there that the 1 kilogram of solution is essentially 1 liter of solution. So when we're dealing with very dilute solutions, molarity and molality are almost the same. But you can see, you've seen that with the HCl. When you have concentrated solution, 12 molar HCl is actually 16 molar. They're not the same. But once you get to very dilute solutions, the molarity and molality are essentially the same. And ppm and ppb, okay, would be essentially the same again because a kilogram of solution total would be essentially be 1 liter of solution. So ppm and ppb, parts per million and parts per billion, would also be essentially the same. And it, they're not the same. What I meant to say is milligrams of solute per kilogram of solution would be essentially the same as milligrams of solute per liter of solution. Okay? So milligrams per kilogram will essentially be the same as milligrams per liter. So that's why sometimes you see ppm shown as milligrams per liter. Because typically when you use ppm, you're dealing with very dilute solutions. Same thing with ppb. Okay, so just a quick check on that idea. For which of the following is the molality of HCl essentially equal to the molarity? Everyone's clicked in. So what's the correct answer? Very good. Ah, no. Oh yeah, I'm sorry. It's B. I thought you all picked A. All right. So in fact, we did show earlier that this was 16 molal, right? But you would expect, since this is very dilute, this is going to be approximately also 0.1 molal. So little m is molality, big M is molarity. Okay. Which of the following, for which of the following is the concentration is essentially equal to 5 milligrams per liter? 5 ppm benzene in water, or is it 5 ppm benzene in ethyl alcohol? The density of ethyl alcohol is 0.79 grams per ml. Let's see if you remember. For which of the following is the concentration is essentially equal to 5 milligrams per liter of solution? Okay, let's see. Correct answer is A. Very good. Why? Because we say then that since this is very dilute solution, 1 liter of aqueous solution is essentially 1 kilogram of aqueous solution. Okay? So, but ethyl alcohol, an alcoholic solution, since the density is only 0.79 grams per mil, you say 1 liter of alcoholic solution, in this particular case, is 0.79 kilograms. So you cannot say that the parts per million there is going to be the same.